HF ham radio. Where do you start? What antenna do you want? What equipment should I use? What band should I operate on? There's a lot to consider, isn't there? Well, let's take a look. Well, hello and welcome once again to the Waters and Stanton video channel. I've entitled this video Ham Radio, Your First HF Station, and this is really targeted at beginners. And I suppose perhaps the first question is, why would you want to operate on the HF bands? Well, that's where amateur radio started. It started many years ago. In fact, it really started on the medium wave bands, but we very rapidly progressed to the shortwave, what we call the HF bands. And when we say HF bands, we mean the bands that cover from 160 metres to 10 metres, 1.8 megahertz up to 30 megahertz. So what is the attraction of the HF bands and why should you consider it? Well, it has a lot to offer apart from its historic connection. It is also quite an amazing range of frequencies because it enables you not only to talk to local people, local stations, local club members if you belong to a club, but it also enables you to talk to stations in other countries. And that really is the attraction. It's the natural radio medium, and it's dictated whether you work a local station or whether you work a station in another country is really dictated by the reflective layers up in the atmosphere. And those layers, those reflective layers, are not stable. They're forever changing. But the fact is that they're free, and it's possible to make a contact with a station in Western Europe, Eastern Europe quite easily with modest power and very modest equipment and antennas. And if you've got a following wind and conditions are really good, then you'll work even further afield, perhaps across to America, perhaps even down into the Pacific, Australia, New Zealand. How exciting is that? But let's come back to basics. You need to start somewhere. So let's look at a simple HF station. But perhaps before we actually look at the equipment, let's look at the bands that you need to consider to operate on. Now, we are at the moment in 2021 at the beginning of a new sunspot cycle. That means to say that conditions will get better over the next few years. Sunspot cycles basically are an 11-year cycle. And at the moment we're at the bottom of the cycle, which means to say that in many respects conditions aren't that good, but they will get better. The good news is that on some of the bands conditions are still very good and make an attractive proposition. Now, the bands that I think you can disregard for the moment are 15 metres, 12 metres and 10 metres, because those bands will most of the time be dead. So the bands that I would suggest we consider are 160 metres, 80 metres, 40 metres and 20 metres. Now, 160 metres used to be a popular band, particularly in the 1950s and 1960s. It really was the band that you operated on when you wanted to talk to local stations. Well, of course, today I think that the VHF bands have predominantly replaced the 160 metre band, but it's still used. The problem with 160 metres is it needs a fairly large aerial in order to radiate an effective signal. I think the bands that we need to look at are 80 metres, 40 metres and 20 metres. Now, you've got to start somewhere. And I think my choice is actually 40 metres. And the reason I say 40 metres is because it doesn't require a particularly large antenna. It's a band that is usually open 24 hours a day. And it's a band that can produce both local contacts and more distant contacts. Now, when I say local contacts, you're likely to quite easily work stations 100, 150, 200 miles away. That's quite easy. And to work stations into Europe, You can do that on a regular basis, again with modest power. So I think my choice to start with would be the 40 metre band, simply because it's always open and it gives you quite a wide range of contacts. So let's talk about an antenna that you would need to operate on the 40 metre amateur radio band. My recommendation would be a dipole. Now a dipole, I've put on the screen here, is basically 20 metres long. It's a 20 metre length of wire, it's broken in the middle, and it's fed with coax cable. We use 50 ohm coax cable for amateur radio, and one side of the coax, the inner conductor, goes to one side of the antenna, and the other side of the coax, the shield, goes to the other side of the antenna. So the antenna is split in the centre. Now you can feed it in that way, and there's nothing wrong in feeding it that way. There is a practical point though, that you have to actually connect the coax cable to the two elements of the dipole. And I would recommend that you consider what we call a balun. That's a matching transformer. Basically, it gives a better match to the dipole. Coax cable is what we call unbalanced. A dipole is a balanced antenna. And I would recommend the diamond balun. The reason I recommend the diamond balun is because it's not expensive, and it not only enables you to connect the coax easily to the dipole, but it forms quite a convenient centre point. Structurally, it's quite an advantage to have this item. So I would suggest the diamond balun. Now, you may say, okay, well, fine, but my garden is not 20 metres long. Don't worry. There are some tricks we can perform. Now, I've put up on the screen here a dipole where the ends are dropped down vertically. So you can get a dipole for 40 metres into a smaller garden. And I think that if you follow the idea of folding the dipole, then you'll get it into most gardens. When you erect an HF antenna, with the best will in the world, it probably is not quite what we call resonant. When an antenna is resonant, it shows a low VSWR. Now, you'll have a VSWR meter probably on your radio, and it's a good indication of whether the antenna is resonant or not. If you've got a VSWR of around about 1.5, 1.7, that's fine. But if it's high, then what you need to do is you need to check the VSWR at the top of the band and the VSWR at the bottom of the band to establish whether the antenna is resonant near the bottom of the band or near the top of the band. Now, if you want to change the resonant frequency of the antenna, this is what you do. If the antenna is resonant at the bottom of the band, in other words, a low part of the band, then you need to shorten the antenna slightly. If, on the other hand, you find the antenna is resonant near the top of the band, that's where the best VSWR is, then you need to lengthen the antenna. So in order to shift the resonant frequency of the antenna higher, we shorten it, and to shift the resonant frequency of the antenna lower, we make it longer. It's always best to make the antenna slightly longer than what it should be. When I say slightly longer, I'm talking about a small, perhaps 20 centimetres maximum, perhaps 10 centimetres. It's always easy to make something shorter. It's not so easy to make it longer. There is a trick there, of course, as well, that if you've made the antenna slightly long, then rather than cutting it, just fold the end back on itself and tightly wrap it with tape. That's almost the equivalent of cutting it short. That gives you the chance of going back and making it longer again if you fold too much back. If you're adjusting the antenna, you want to adjust it on 40 metres, you want to adjust it in, I would say, 5 centimetre adjustments. 5 centimetres will make a noticeable difference to the resonant frequency. Now, you may have heard people discussing the heights of antennas, and there's no two ways about it. The higher the antenna, generally speaking, the better it works, but it works very well at low heights as well. If you can only get your antenna up around about 5 meters, it will still work. It will work better if you can get it up at 7 meters, and it will work better still if you can get it up at 10 meters. But don't worry too much if your antenna is low. It will still work. Now, when it comes to equipment, your license may have a power limitation on it. You can't run more than 10 watts or 20 watts or whatever. It depends on what country you're in and what license you've got. But I would strongly recommend that you purchase a transceiver that will give a reasonable amount of power. I would say buy one of the traditional 100 watt HF transceivers. The reason is that probably, even if your license has a restriction on it, you will progress and have a license that the next stage up, which gives you more, allows you to have more power. So I would say go for a 100 watt transceiver, and you can always increase your power without having to purchase a new transceiver. All modern transceivers have power controls, so if your power limitation is 10 watts, you can easily turn it down to 10 watts. So my recommendation would be, in terms of economy, long term, consider a 100 watt transceiver. I would also encourage you to purchase a transceiver that's got an internal antenna, we call it an ATU, an antenna tuner, because that enables the transceiver to match your antenna almost perfectly, and then you get best transfer of power. So consider buying a transceiver with an internal antenna tuner, and most of the modern transceivers now have those, and they're automatic, so you haven't got too many controls to worry about. Also, do remember that most amateur radio equipment requires 12 volts. There's not many transceivers that have a built-in power supply. They are designed to work on 12 volts or 13.8 volts, which is the nominal sort of voltage. You can pick up a power supply quite low cost, but remember, the power supply is something that you probably won't change very often. For a 100 watt transceiver, you need a power supply that will quite happily deliver 20 amps at 12 or 13.8 volts, which, as I say, is the nominal voltage. So you need a 20 amp power supply. There are two types of power supplies. There's what we call a switch mode power supply, which is quite lightweight and sits nicely on the desk, or you can have what we call an analog power supply, which is heavier and the more traditional power supply. The switch mode power supplies did have a reputation of creating noise, but the modern ones are very well suppressed, so I would have no hesitation in suggesting that if you want to have a lightweight, compact power supply, consider a switch mode power supply. But buy a reasonable one, because that power supply will probably stand you in good stead for quite a long time. And if you upgrade your transceiver, you can still use that same power supply. So do you buy a new transceiver, or do you buy a second-hand transceiver? Well, there's nothing wrong in buying second-hand HF transceivers. I would suggest that you steer clear of the very old valve types, because there's more controls there. They're quite old and they will need a bit of maintenance. So I would suggest that you try and look at a solid state HF transceiver, probably a fairly recent design, and I would suggest you look at Yaesu and ICOM. They're the main manufacturers. They're reliable brands, they've got good backup, and they work extremely well. So have a look for Yaesu and ICOM. If you're going to buy a new HF transceiver, then the brand that is the best selling at the moment is the ICOM 7300, or rather say the brand is the best selling transceiver at the moment is the ICOM IC 7300. It's competitively priced and it works extremely well. And it does have a little bit of a bonus, because it also covers a couple of VHF bands. It covers the 6 meter band, which is 50 megahertz, and it covers the 4 meter band, which is 70 megahertz, and they're both really regarded as VHF bands, and quite interesting bands as well. So you get a bonus there. If you're looking for a transceiver that covers the complete frequency range from HF right up to the UHF bands, then look at the Yaesu FT991A. So those two transceivers are ones that I would suggest you look at. So we've talked about the antenna, we've talked about the transceiver. The transceiver comes with a fist microphone, and there's nothing wrong with the fist microphones, they work very well. So what else might you want? Well, actually, with those two items, the transceiver and the antenna, then you are ready to go. SWR meter is probably another item that you might want to consider. The SWR meter is a handy device because it indicates the SWR and it also indicates the power output. And you might say, well, isn't the one built into the transceiver? Well, there is, but there are advantages of having an external SWR meter. For a start, it's got a much larger meter. It tends to give you a very good indication of power output and a very convenient way of measuring the SWR, and it alerts you to the fact that there might be a problem with your antenna system. Because your transceiver will almost certainly have an internal what we call an antenna tuner, some of the antenna faults cannot be noticed on the internal SWR meter of the transceiver. If you have an external SWR meter, then you're more likely to notice any problems with the SWR that starts to creep up. So I would say that if you are on a budget and you can't afford one, don't worry. But if you can afford one, then it's a good item to have. And that really is your HF station. You've got a 40 meter antenna, you've got an HF transceiver, you may have an SWR meter. You're going to operate on a band which is open 24 hours a day. There is another bonus with 40 meters, and that is that the antenna, the dipole antenna, will also work on the 15 meter band. But at the moment, the 15 meter band is rarely open. But we will see times when it will open up occasionally, and it will give you the chance to work stations much further afield. Now, as you progress with your ham radio, you'll want to change your antenna to an antenna that is multiband. I've tried to keep this as simple as possible. It's for the first time operator. Now, another thing that I suppose if you've been in ham radio for a long time, you tend to not to really appreciate, but there is that first QSO sort of fear. And I can remember my first contact on ham radio, that was with Morse code, and I was so scared that halfway through the contact I couldn't copy the Morse code and I switched the transceiver off. Probably most of you will be operating single sideband, and it's quite understandable that you can be mic shy. Well, I think you really have to take the plunge. It's rather like jumping in a swimming pool, which is perhaps not as warm as you hoped, but you soon get used to it. Just sort of make yourself a cup of coffee, have a listen, see the style of contacts. Don't worry if you think, well, what am I going to say? You will soon find on the bands that there are stations that are what we call having rubber stamp QSOs. They're putting out CQ, and stations are calling them, and the stations that call them give a report, their signal, the strength, their name, their location, and that's it. Now, they probably are the sort of contacts that you want to cut your teeth on initially if you're mic shy. So have a listen on the 40 meter band, and you'll soon hear a station with probably quite a strong signal calling, and they start to work through a whole load of stations very quickly. And all you've got to do is, hi there, this is G3OJV calling. They'll come back to you, say, G3OJV, you're 5 and 9 or whatever. My name's Tom, I'm in the Ukraine. And you go back and say, thank you very much, Tom. You're also good and clear, you're 5 and 9. My name is Peter. I'm located in southeast England, and I'm very pleased to work with you. Thank you for the contact. 73, back to you. That's the sort of contact that you want to cut your teeth on. Once you've had some of those contacts, you'll become more confident. Now, a lot of you may have no problem with it at all, but there are those, and I can quite appreciate it, that are mic shy and they just don't know what to say. If you're a member of a club, of course, you probably get one or two club members that will sort of encourage you to go on there and they'll have a chat with you, and you'll be more comfortable because you know them. But if you're starting from scratch and you're not a member of the club, then, and you're mic shy, look for those what we call rubber stamp QSOs. They're very short, but it cuts your teeth, gives you confidence. So I hope that that has been useful. Don't forget that we at Waters and Stanton operate a very active retail shop, mail order. Unfortunately, you can't call in at the shop at the moment, although things might change in the future. But we operate a good mail order service, and you can always pick up the phone and chat to one of our sales guys. And if you've got any queries, they'll guide you through. And if you're not sure which equipment you want to buy, talk to us. We'll guide you through. If you want wire for your aerial and cable for your antenna, we can supply that as well. So don't be frightened to give us a call. So if you are a newcomer and you've got your new license, well done, congratulations. It's a great hobby and you'll get a lot of enjoyment out of it. If you haven't got your license yet, but you're about to take it, well, good luck to you. Stick at it, and I think that probably you'll have no problems in getting through. Because if you're determined, you'll pass the examination, and probably you'll get your initial license, which will have some limitations on it, and then you can upgrade to a license which will allow you to operate on different bands and more power. There we are. Thank you for joining me on this channel, and don't forget there's a lot of other videos on this channel. If this has been helpful, please press the subscribe button and that'll alert you to future videos. In the meantime, thank you for watching, take care. Ham radio is a great hobby. I've been doing it a long time now, 60 years would you believe? Still at it. In the meantime, take care.